Hello and good morning. Today I'm going to show you the review of the last test, which is chapter 11 and section 12.2. So hopefully that will give you a little bit summaries for this chapter. So let's go ahead and get started in here. The first one right here, is a popular brand of pen. Is available in 12 colors and 4 writing tips. How many different choices of the pens do you have with the brand? Well, so we are looking for the number of the choice in here. So if you have a number of the choice, you can just multiply M and N all together, okay? So this one, since you have 12 colors, you can just using 12 times the region tips in here, okay? So let's go ahead and multiply the 12 times 4, and that will give you 48. Okay, so if you the first choice you have an M, the second choice you have an N, you can just multiply M and N together. So the total here should be 48. All right. Okay, the second one, the restaurant offers the following limited lunch menu. So you have a main course, vegetables, beverage, desserts. So if one item is selected from each of the 4 groups, how many different ways can a meal be ordered? All right, so this one is similar to the first one. So we have 4 groups. So the first group, we have 3 choice. The second group, we have a peas, squash, cauliflower, eggplant, so that's 4 choice. The beverage, we also have got 3 choice. The desserts, we also got 3 choice, okay? So since you have a 4 group, so we're gonna multiply all these together. So be 3 times 4 times 3 times 3, all right? So that would be 12 times 9, so that would be 108. Okay, so you have a total of 108 choice can be ordered. Number 3, in a encyclopedia of language, the author presents 5 sentences that make a reasonable paragraph regardless of their order. So the sentences are below. So we got 5 sentences here. You can read it. So how many different orders can the 5 sentences be arranged? So since this one is set of different orders, so orders matters, all right? So all the matters, we're gonna look at the first choice, okay? So, and then the second choice, and then the third one, and then the fourth one, and the fifth one, right? So we have 5 sentences, so anyone can be the first choice, so that will be 5 of them. After you got a first choice, you only have 4 there. So you have 4 for the second one. Okay. And then same thing, you're gonna have a 2 already out. So you're gonna have a 3 left for the third one. And then you're gonna have a 2 left for the fourth one because all 3 are taken and only the last one there. Okay. So this one can be 5 times 4 times 3 times 2 times 1. And actually this one is also called equal to 5 factorial. Okay. So if you multiply these together, that's 20 times 6. So that's 120. All right. So you can use this one as 5 factorial or using the exponential I have in here. Okay, the first choice you have a 5, second, third, 4, and 5th, and so on. All right. Number 4, this one is just evaluate the factorial expression. The factorial, if you have an n factorial, that's n times n minus 1, n minus 2, all the way to 3, 2, and 1. Okay, so if you have a 5 factorial, you're gonna have a 5 times 4 times 3 times 2 times 1. Okay, and then this one is 120. You have a 1 factorial is 1, and please remember, the 0 factorial is 1, it's not 0. All right. So this one, I can go to expand the 11 factorial all the way to 1, or I can have 11 times 10 times 9 and then times 8 factorial. Since my denominator has an 8 factorial, so these two will be canceled out, okay? And then you just multiply these two together, so there'll be 99, 99 times 10, so that's 990. All right, so that is this one. If you don't want to use this one, you can also use a calculator to find the factorial. Okay, so let's go ahead. Let me show you 11 factorial. So you go to 11 and then go to math. And then we're going to use the probability here. Okay, when you got to the probability, you can see the number 4 is the factorial. All right, and then we hit enter. So we have this one right here. And then we have an 8 factorial, so same thing. I can input 8 and go to math and go to the probability and I hit number 4, that's 8 factorial, okay? So now you can divide these two together. All right, so that is another way to do this one. But I think, you know, if you just expand until 8 factorial and cancel out, that'll be even easier, okay? All right, number 5, using a formula to evaluate the following expression. So if you have an NPR, that means all the methods, okay? So we have this is called a permutation and then the combination NCR. NPR, this means all the methods, okay? All the methods. NCR is a combination, so the order doesn't matter. Okay, so that's the difference of these two. And then if we have NPR, that is n factorial divided by n minus r factorial. Okay, so that is using the formula in here. All right, so NPR, okay, so NPR is n factorial divided by n minus r factorial. That is NPR. Okay, so if we have this one right here, that means my n here is 9. So I have a 9 factorial divided by n minus r. All right, so I have a 9 factorial divided by 3 factorial. All right, so we can go to evaluate 9 factorial all the way. 9 times 8 times 7, 6, 5, 4, and 3 factorial, right? And then I have a 3 factorial here. This is can be canceled out. Okay, so that's a big number in here. Okay, so you're gonna go to multiply this 1 by 1 in here. We can get an answer. We can say 9 times 8 is 72 times 7 times 6 is 42. All right, and then 5 times 4 is 20, right? So we can multiply these together in here. Okay, so that's 72 times 42 times 20. All right, so we have a 60480. All right, so that is using the formula for this one. I can also using the calculator instead of the formula. I think using the calculator to evaluate this one would be even easier. All right, so I will input n here is 9 in first, okay, and then similar go to math, and then I'm going to the probability in here, and then you can see the second one. I have an NPR right here, right? And then I input the R in here. R here it is 6. Okay, so I hit enter. So now I got the same answer exactly. All right, so this one you have this permutation formula under the TI 83 or 84. Okay, calculator. So that's really convenience in here. All right, so either way, you can either use the formula or you can use the calculator. All right. Number 6, for a segment of a radio show, a disc jockey can play 5 records. If there are 10 records to select from, in how many ways can the program be for this segment be arranged? Okay, so first you have a n here is equal to 10, right? And you only want to play 5 records, so that is 5 of them in here. And of course, you have to think where the radio show which song you play first, which jockey you play first will be different. The answer is yes. So this one order matters because this need to arrange in the order. So apparently this is using the NPR. All right. So N here is 10 and R here is 5. So this time I'm going to just straight using the formula will be much easier. Okay. So I input 10 in here using the calculator and then go to math and then go to the probability using the second one, NPR, and then I type 5 in. All right, so I have a 30240. 30240. So I have these many different ways to arrange them. All right, so that is how you do the NPR in this case. Number 7, determine whether the following problem involves a permutation or combination. It's not necessary to solve them. Okay, so in order to distinguish the permutation and the combination, mainly you want to see if all the matters or not. Okay, how many different 4 data password can be formed from the data this many if no repetition of the data is allowed. All right, so this problem, since password, as we know, password order matters. Okay, so this one apparently you will need to use the permutation. Okay, mutation for the first one. Okay. Because what? Because the order of the data you select does matter. All right. So that's why you choose the permutation. Okay, we're gonna use the NCR to evaluate the combination. So the NCR formula here is n factorial over n minus r factorial, and then times r factorial. Okay, so that is the formula in here. And I can use this formula. So if I have n here is 9, n minus r. All right, so that is my factorial. So 9 minus 5 will be 4 factorial, and then it's 5 factorial. I will expand the 9 factorial into 9 times 8 times 7 times 6 times 5 factorial, and these two can be canceled out. Okay, and then 4 factorial, you have a 4 times 3 times 2 times 1, right? So I have a 9 times 8 times 7 times 6. These can be canceled out. These can be canceled out. Okay, so I have a 21 times 6. So that's 126. All right, so that's using the formula. Again, very similar. You can use the calculator for this combination as well. Okay, so I have a n here is 9, and then go to math, go to probability, and then I can use my NCR here. Okay, and then input this one is a 5. So I got 126. So exactly the same as your formula in here. Okay, so either way, it will work as long as you calculate, right? Okay, number 9. An election board asks a voter to select 4 city commissioners from a group of 12 candidates. Okay, so you can see I want to have a R here is 4, right? And here is 12. Okay, in how many ways this can be done? All right. A 4 city commissioner can be selected from a group of 12 candidates in how many different ways? Well, one thing is they are all commissioners. They didn't have a specifically talking about a different role. All right, so I'm gonna assuming they are all the same. So, as long as you got selected. So I think the order will not matters in this case. So I will using the NCR. Okay, so N here is 12, R here is 4. All right, so I can just using the calculator for this one right here. Okay, so I go to 12, go to math, and then go to probability using my NCR. Okay, and then here, this one is 4. So I have a 495. Okay, so I have a 495 different ways to select 4 candidates. Number 10, explain how to distinguish the permutation and the combination problem. Okay, as we have been talking about, permutation involves situation in which order matters, and combination involves a situation in which the order all right, so I think there's a little bit twinkle in here. This in which the order really doesn't matter. All right, so I think the A is the good one in here. Okay, if you look at the B, permutation in which can be chosen multiple times, no, that's not the correct answer. Permutation involves situation only one chosen once, combination involved in which okay, I apologize that this got truncated in here. All right, so looks like the correct answer, the makes sense here is A. Okay, this one should be permutation involves situation in which order matters, and combination involves a situation in which order of the items make a mess, no difference. Okay, so that is the entire sentence for the first one. Okay, permutation problems involve situation in which order matters, and combination problem involves situation in which the order of the items makes no difference. Okay, so that's the correct one. Number 11, a 12-side die is low. The set of the equally likely outcome is this one. So 1 to 12. Okay. Find the probability of learning a number less than 7. All right. The number is less than 7, the probability. So we want to find a probability that a number is less than 7. All right. So how many are less than 7? We can see from 1 to 6. So I have a 6 of them is less than 7. All right, and this one, so this is the total number that is less than 7. And what is the total one? Total one is 12. Okay, so you need to using the number you have and divide by the total, or call the sample space. Okay, so the sample space here is 12, or the total of the outcome is 12. So 6 divided by 12, you simplify. Okay, simplify in here. So that's 1/2. So the probability of learning a number is less than 7 is 1/2. All right. Okay. Very similar for this one. The set of equally likely outcome of this 12. Find the probability loading a number that is less than 20. Well, so I have all the number are less than 20. So I have a 12 less than 20, and the total outcome is also 12. Okay, so 12 over 12 will be 1. So that's 100%. All right. So you need to type it in an integer or a simplified fraction. Okay. So this one, you need to use a simplified fraction. And if this one is integer, you have to type in an integer. Remember the format for that. All right. Okay. Number 13. In one common system for finding the grade point average or GPA, A is 4 point, B is 3 points, C is 2 points, D is 1 point. If we got F is 0. Okay, so this the GPA is calculated by multiplying the number of the credit hours for course and the number of the assigned to each grade, then adding this course divided by the sum by the total number of the credit hours. Okay, this one is not necessary to tell you, but it's already telling you how to calculate. All right. So this is table is a weighted. This is called a GPA is a weighted bin, right? We want to calculate the GPA. Okay, so the GPA are called weighted mean. All right, so we're going to using the sum of the weight times the x, which is each grade. Okay, divided by the sum of the weight. All right. So the sum of the weight is the credit hour. So the credit hour here, I have a 2 plus 2 plus 3 plus 2. Okay. So let's go ahead calculate this one. That's 479 credit hours. Okay. And that is my denominator. So I have a total course weight here is 9 credit hours. Now we're gonna look at the points. So the B here, you look at it, the B here, you got 3 points. So that's a 3, 3, 3. A here is got 4 points, but there's not A here. Okay. C here is 2 points. So you're gonna multiply all these together. All right, multiply all these together and then add them together. Sigma is a big sum here. So it's 3 times 2 plus 3 times 2 plus 3 times 3 plus 2 times 2. All right, so we're gonna go to multiply first before you add it. So that's 6 plus 6 plus 9 plus 4. All right, okay, so that's 12 plus 9 will be 21 plus 4 will be 25. Okay, so 25 divided by 9. All right, so we have a 25 divided by 9, so it's 2.777. This one you want to run to the nearest hundreds, so be very careful. Look at the format here. Nearest hundreds, so that means 2 decimal point, right? So I have a 277 and keep going on in here. So I will run to 2.78 because it's nearest hundreds is 2 decimal point. All right, nearest tens will be the 1 decimal point. Nearest thousandth will be 3 decimal point. All right, so that is how you calculate the weighted bin in here. Okay. You can also calculate the weighted bin in a calculator, but in this case, since the number is not that many, so do it by hand actually is pretty straightforward. Okay, I can also show you how to do this one in a calculator, but depends on what kind of calculator you use. You might need have a little bit of different syntax. All right, so I can go to put this one in a table. Okay, go to the state and then edit. Okay, and then you can see I will clear, enter, everything is gone, clear, enter, everything is gone. All right, so the first one you want to input the points. The second one you want to input the credit hours. Okay, so the B here is so we have a B, C. All right, so 3 credit hours, 3 credit hours, and then I'm sorry, B is 3 points, B, C. Okay, B is 3 points, C is 2 points, and then the credit hours is 2232, 2232. All right, so I will go to state again and then go to the calculation, and I'll go to the one state calculation. This one is the L1, And the frequency list, we need to input L2. So second 2 is L2. All right, and then we're gonna go ahead, hit calculate. So the first one, the X bar, the weighted bin 2.777. This one is your weighted bin. 1 to 2 decimal point is 2.78. All right, so that is how you calculate this one right here. For some of the calculator, if you use TI-83, it doesn't have this interface. Okay, so you go to the stat cal using variable cal. All right, so some of the calculator do not have a frequency list. If you don't have a frequency list in here, you will need to input your L1 and then comment L1, comment L2 in order to calculate. If you use TI-83, okay, so you need to input second one and then comment second two. So you need to show the L1, L2 in order to calculate the weighted bin. Okay. All right. So that is using the formula and using the calculator. Okay. Last one here. Determine whether the following statement makes sense or does not make sense and explain your answers. Okay. I am working with a data set for which neither the bin nor the median is one of the data items. All right, so this one, you kind of need to understand what is a bin, okay, and what is a median. All right, so before we look at the answer, let's look at what is the bin. The bin is used every data item, and then divided by the number of the data. Okay, so that's the bin. This bin can be affected by either the very high data value or very low data value. So we call this is an outliers. The bin will affect by the outliers, right? If you have a data really high or data really low, it really affect the bin. All right, the median is you pick the middle of the data, depends on the even or odd number. Okay, so you always pick the middle of the data. And if it's an odd number, you pick exactly in the middle. If it is an even number, you will need to pick the middle 2 and then divide it by 2. All right, so the median actually doesn't affect by the outlier. Okay, so that is this one right here. Okay. All right. So this one is that the data set neither the bin nor the median is one of the data items. So that is probably correct because the bin usually is not really the same as any one of the data item. Mostly, if it's one of the data item, it's very, very rare coincidence. Okay, it's not necessary to be a data item. And the median, like I said, if it's an odd number, it will be one of the data item in the middle, right? But if this median, if the data number is an even, you're gonna have to pick the middle 2 and then divide it by 2. So the average of the middle 2 is not necessary to be one of the data items. So this one actually making sense. Okay, so that makes sense. And then this one is doesn't make sense because the median must be one of the data item. No, the median don't have to be one of the data item. If it's even, you pick the average of the middle 2. Okay, and that one usually is not one of data item. All right. Doesn't make sense because the bin must be one of the data items. No, the bin is you add all of them together and then divide by the number of the data, so it's not necessary. Okay. The statement makes sense because it is possible to have a set of the data that does not include a bin or median. Actually, that is correct. Okay. Let's look at the last sentence. The statement does not make sense because the bin and median must be both be one of them. This is even absolutely wrong. Okay. All right. So the correct answer should be C in here. All right. So that will provide you a quick review for the chapter 11 and section 12.2 Okay, hopefully that will help you for the last test. All right, let me know if you have any questions.